Hey everybody, and welcome to Math 152, Functions 2, and Pre-Calculus Online. My name is Sean, and I'll be your instructor this semester. I'm looking forward to getting started with all of you. I'll introduce myself a little bit more thoroughly in the welcome discussion, and I hope to see you there. But for this video, I wanted to just quickly go through an overview of the topics we'll be covering, what you can expect the course to kind of look like, and then how to get started with the class. So here we go. A quick overview of the topics we'll be covering. So you've come a long way to come up to through college algebra and or if you've taken something equivalent in high school and now you're here in pre-calculus, and basically we're here to arm you with the rest of the library of important functions. And what's a function? It's a relationship, it's a model, it's something that mimics some pattern we see in reality. So exponential functions, they model things that grow in proportion to how much you have of them. So interest in the bank, populations, things like this. Exponential decay, we have radioactive decay, things that also decay in proportion to how much there is of the thing itself, right? So that's just something we see in the world, and we can model that with math. Same with logarithmic functions, as we'll be coming up with in the second chapter there. Logarithmic functions are the inverse to exponentials, and they mimic things that spike really quickly, but then taper off over time. So, one example I like to use is this is our understanding of numbers when we're children. Seeing the difference between 1 and 2 and 3 is pretty quick when we're kids, but then seeing the difference between 4 and 5 or 10 and 15, that takes more time. And it's more of a gradual growth over time instead of those first few numbers that we really nail. So the other functions that we'll be looking at, periodic functions, things that oscillate. So things that fluctuate, temperatures, sleep cycles, day and night, tides, anything that oscillates or fluctuates can be modeled with a periodic function, which is a startling number of things. So it's a huge category to have covered. Rational functions cover a lot of different things, and we'll dig into them, but essentially it's a ratio, a fraction of two polynomial functions. Polynomials can mimic a ton of stuff, so a ratio between the two is kind of like a comparison of two functions. And then lastly, we'll be combining and inverting all of the functions that we know so far. So if I stick a sinusoidal function or periodic function inside an exponential function, what happens? It might start growing more between the waves, things like that. So this is just a quick kind of overview of the types of behaviors we're going to see, but we're going to be looking at these things from the algebraic perspective, the graphical perspective, numerical, and again, these verbal descriptions like I'm doing here. And then lastly, we'll be setting you up with some preparation on limits, which is just kind of thinking in the long run, or thinking about the idea of approaching in a mathematical sense. So how do we approach some value, or what happens when we let time go on forever? What does this machine do? Where does this rocket end up if we let time keep going? Things like that. So this notion of when the independent variable approaches something, what happens to the dependent, or what happens to the response? So for those of us who are not going on to calculus, this will kind of cap off all the major patterns of behavior that you can use to model situations in the real world. And then for those of us going on to calculus, this is setting you up to actually do calculus on these things, which is the next level of excitement. So we're going to take our time with each of these, and some of them are going to be more challenging than others, just based on our own math history and the gaps that we all bring. Okay, and we all have those things, so just be prepared for that. But we're gonna find the fun stuff in the struggle together. So we're going to use the class discussion. I'm saying it here now. We're going to use the class discussion a lot to stay in touch and to make sure that we are, working through those problem spots together. And sometimes, most of the time, it's going to be hearing from me, but you're also going to hear from classmates on their perspective, and that can be immensely helpful. I often say students speak each other's language, so the more that you can talk with your classmates in that class discussion, the better. So the last thing I wanted to cover was just the course structure. And I'm not going to pull up the class here right now. I just kind of want to loosely explain what you can expect. I am at this point, I'm not going to have a lecture video for every single section. However, there will be some, and I will say that here. And I'm going to try to make as many as I can because I do think they're important. Students find them helpful who use them, and so I'm going to put them up as regularly as I can. But what is great about this course inside Lumen, which I haven't mentioned yet. Lumen is the math-friendly software that we'll be using. So it sits inside Blackboard, but it is not Blackboard. Lumen is designed to be engaging with math online, whereas Blackboard is really not. So within Lumen, there are these interactive readings. So these are much different than just reading a textbook and having a reading assignment there. There are examples within it that you can interact with. You can enter your answer, see how it goes. There's video tutorials. And there's other interactives as well, like web apps and things like that. So you get to play with sliders, play with graphs, and see how these things work. So it's very, very different. And this is going to be a core part of the content for learning. Okay, there'll be some supplemental readings, some other videos, and things like that. But a lot of it's going to come from this interactive reading. And this is a highly developed piece of content, and I hope you enjoy it and get your money's worth out of it. It is free, actually. But anyway, so there are also practice problems and practice sets. A lot of these will come with a video tutorial that that pair with them. Please don't, just jump into doing the practice assignments. You're going to want to do the readings. You guys gotta kind of know the stuff in your bones because the exams are cumulative. There's a cumulative final at the end, so making sure that you're doing every element of the course. It's there by design, very intentional, and I hope you avail yourself to all of it. So there's practice problems. There are quizzes. A lot of these you'll have instant feedback, which is great because I know we're working at all different times, and so I try to have as much of that as possible. But I also review and grade, everything by hand. That just takes me a little bit longer to get around to. So quizzes are like that. Then you'll have your exams. You'll have the midterm and final. The final exam is proctored. I am saying that now so that you have some time to prepare and think about it, about what you're going to do. I have a whole document in the course about how we set up proctoring for the final exam. But just to kind of put that bug in your ear now so that we're set up for success later. And then the other major components of this class is the community problems. And so there are 8 of these, so it's about every other week where we're going to tackle a problem set together. And this is the thing where timing is of the essence because these are going to open on a Monday and be due on a Wednesday. Okay, so you'll have that 72-hour window to just slightly less than, because it'll open at 8 on Monday and be due Wednesday night. The goal there is that we can have a timely discussion, right? So everybody posts their attempt to the problem. We're going to have some differences. We're going to have some errors. We're going to have some good stuff there too. But the goal is to have everybody's posts up by Wednesday so that Thursday to Sunday we can all kind of digest it, see each other's approaches, because you learn as much about, getting feedback from me, graded feedback from me, as you will from seeing your classmates tackle problems, because we're going to tackle these things in different ways, and that can just, draw different connections in the brain. It's a wonderful thing. So I'm excited about those. And so again, about every 2 weeks, so like every week you'll have pretty much a quiz and then community problem and quiz and so on. So we try to keep it pretty simple and predictable so that we can stay focused on solving problems, forming connections with the mathematical ideas. So we're coming up on 10 minutes, so I'm sticking pretty close to my time here. This is roughly what you can expect. Definitely need you to read the syllabus though in detail. Everything is there for you. So in the vein of getting started, there is a module 0 that is basically just a checklist of all the different things and course elements you're going to need to be familiar with before starting the class. So jump in there, jump into the welcome discussion. I hope to see you all there, put some faces to names, and start making connections with you all. But I hope you have a great start to your semester. I'm looking forward to working with you, and we'll see you there. Bye-bye.